We are team number 7, and in today's video we are going to be explaining the Cramer method. First of all, what is the Cramer method? The Cramer's rule is a method that uses determinants to solve systems of linear equations, as it allows you to find the value of just one variable. To use this rule, all you need to do is set up an augmented matrix and calculate the determinant of the main matrix. Then, to find the solution of one of its variables, we replace the column of this variable in the main matrix with our constants, or the values our equations are equated to. After that, you can calculate the determinant of this variable, and then you just have to divide this determinant of the variable by the determinant of the main matrix. And you can do this with each column to get each variable. What you have to take into account is that the determinant of the main matrix has to be a number different to 0. Now we're going to demonstrate step by step how you would solve a system of equation with the Cramer's rule.
The step 1 is to check that our equation is arranged in the correct order. First the x factor, then the y factor, then the z factor, and in the other side of the equal sign you should have the independent variable. So our determinant would look like this. First the x column, then the y column, and last the z column, and we cross out the independent variable column. To solve the determinant, we're going to use the method montante. In the first step of the method montante, we look for a pivot, in this case, -1. And if you see the lines, it's because we're crossing out the others number, the numbers that are in the row and the column of the pivot, like 4 and 6 and 3 and 2. Then the others number are going to be for our second determinant. The spots of that are our other number are going to be part for finding the numbers for the second determinant. But how we find the numbers of the second determinant? There is, first we multiply the pivot times the number that is in the spot of the number we want to find. So it's going to be -1 times -4. This is going to be rested by a multiplication. This multiplication consists of two numbers. The first number is the number that is in the row and the column of the pivot and the number in the spot. And the second number is going to be the number of the column and the row of the pivot and the number in the spot. So it's going to be -1 times -4 rest by 2 times 4. This is going to be divided by our previous pivot, but we don't have, so it's going to be only 1. And it's -4. We do this for all the others number we want to find. So it's going to be -14, -13, -4, and -9. But there is an important step that are the cofactors. Cofactors help us to know what positive or negative sign our pivot has. In this case, our pivot that is -1, that is in the position of that place -1, is having a cofactor of -1. So this -1 is going to be multiplying the second determinant. So for solving the second determinant, we first multiply the number that is in the first column and the first row times the number that is in the last column and the last row. This multiplication is going to be rested by another multiplication that is going to be the number that is in the last column and the first row times the number that is in the first column and the last row. So it's going to be -14 times -9 rest by -4 times -13. This is going to be divided by our previous pivot that is -1 times the cofactor. So it's 74. And the determinant of the result of the determinant is going to be 74. Then to find the xy variables, we also find the determinant of these xy variables, but with certain rules. For x, we cross out the x column, and instead we use the independent variable. So it's going to look like this. First the independent variable, then the y variable, and then the z variable. So first we're going to search for x variable. We use again the method montante. We use a pivot, in this case 2. This 2 is going to be multiplied by the number that is in the spot we want to search. This multiplication is going to be rested by another multiplication, and the first number is going to be the number that is in the row and the column of the pivot and the number in the spot times the number that is in the column and row of the pivot and the number in the spot, all divided by our previous pivot, but we don't have it, so it's 1. It's going to be 2 times 6 minus 5 times 4 over 1. It's going to be -8. So also we have to remember our cofactor. In this case, the pivot we choose has a cofactor of -1. So our second determinant is going to be multiplied by -1. We search up for all numbers. So our second determinant is going to be -2, 32, 0, and -26 times -1. We use the crossout method. We multiply the number of the first column and the first row times the number of the last column and the last row. This multiplication is going to be rested by another multiplication. The multiplications consist of the number of the last row and the first column times the number of the last column and the first row. All this divided by our previous pivot, in this case 2, times the cofactor. So it's going to be minus 8 times minus 26, rested by 0 times 32, that it converts to 0, over 2 times our cofactor, that is minus 1. This is going to be minus 104. We repeat the same with the rest of the variables, y and c, but also with the correct order. X variable first, the y column variables are going to be crossed out, and in that column, we're going to put the variable independent column, and last, the c column. And in c variable, the determinant is going to be first x column, then y column, and in the c column, we're going to cross out, and instead of putting c column, we're going to put the independent variable. We solve for each determinant by Montante method, and our determinant general is going to be 74, our determinant of x is going to be minus 104, our determinant of y is going to be 181, and our determinant of c is going to be minus 64. Then we use the Cramer's rule. We divide the determinant of our variables by the determinant of general. So it's going to be the determinant of x by the determinant of general, or determinant of y by determinant of general, or determinant of c by determinant of the variable. So for x, it's going to be minus 104 over 74. It's going to be minus 52 over 37, around like 1.405. And for y variable, it's going to be 181 over 74. It's going to be 181 over 74. That is around 2.446. And for c, it's going to be minus 64 over 74. That is going to be 32 over 36 over 37 negative. That is around of negative 0.865. And that is your answer.